Hello everyone, this is the first lesson of physics, unit 6, 6.1, page 128 and 129. The topic is about waves and some types of waves, transverse and longitudinal waves. Here, this picture, it shows the two types of waves, the longitudinal waves and transverse waves. Introduction. If you look at this picture, it shows some waves in water. It's like if you drop anything, let's say a stone, if you drop a stone into a pond, ripples spread across the surface. These are the ripples spreading across the surface. The tiny waves, these waves, it's carrying energy, the energy of the stone that you dropped in the water. Okay, so here what is happening, you dropped the stone here, then the effect of it shows as waves. So the energy here is transferring as these waves. Okay, so but one thing we should note here, which is the water, it's not moving. Okay, so the water, let's say molecules of water are not moving here. What is happening, water molecules are staying in its place. It's just waving, vibrating up and down, up and down. So here it's showing, but there is no flow of water across the pond. The wave effect is just the result of up and down motion in the water. So waves, it's not only about water. Well, waves are not only in water. Sound travels as waves, and also light. Some terms we should note about when you will study waves. You should know about these terms. Firstly, oscillations. If you will look at this drawing, see how this is moving backward and forth. So to and fro movements of the coils are called oscillations. Okay, here as you can see, this is the coil. Okay, it's moving in these two directions. Okay, this movement we call it oscillation, or another definition for it, it's movement back and forth in a regular rhythm. Movement back and forth in a regular rhythm, this we call it oscillation. Number 2, or the first type of waves, transverse waves. Look at the drawing. See how these waves are moving. Okay, so when the oscillations, what do you mean by oscillations here? It's, let's say, this point. Okay, it's going up and down. Okay, this, it's the oscillation. So when the oscillations are up and down, from side to side, up, okay, down, okay, from this side to this side. Okay, here we have direction, the up and down side. Okay, so this we call it transverse wave or transverse waves. Again, when the oscillations are up and down from side to side, this is called transverse waves. You should here focus on up and down. Is it clear? Then the second example, or the second type of waves, which is longitudinal waves. Look at the picture. See, here what is happening, the oscillations are not going up and down, but they are going forward, backward. See, look at his hands, okay? It's just moving to this direction, and then this direction. So when the oscillations are backwards and forwards, the waves called longitudinal waves. Again, a quick review. Transverse and longitudinal waves, two types of waves. In transverse, the oscillations are moving up and down, but in longitudinal waves, they are moving backwards and forwards. More information about longitudinal waves. Waves here, if you look at this spring, it consists of, if you look at this spring, it consists of coils. These are coils, okay? Moving the end coil of the spring backward and forward produce traveling effect, or it produces the oscillations. So the waves are bunched up sections of coil when stretched out, sections in between. These sections are known as compressions and refractions. If you will focus on this coil or in this spring, you will see the coils. Here are far from each other. There is a gap, there is a distance between them, between the two coils, okay? But here the coils are compacted, okay, stick to each other. So in longitudinal waves, it forms compressions and refractions. So this area, it's the compression, and this area, it's the refraction. Some examples of waves, okay? We have waves in water, waves in air. For example, if you'll have a question that says, what kind of waves are there in water? You will say transverse waves. What kind of waves are there? There are in air, or another example of air. If you want, you can say sound, okay? Sound, what kind of waves there in sound? You will say it's longitudinal waves. When you will study waves, there are some terms you should note about waves, or there are some terms you use to describe the waves. The first term is speed. Because the waves are moving, so it will move with a specific speed. This speed, it depends on the kind of wave, and it depends on many other things. So each wave has specific speed. So how to measure the speed? As we know, we usually use this unit, meter per second. So speed, it's one of the terms that describes the wave. It's used, or it measured with meter per second. Number 2, frequency. Frequency, what do you mean by frequency? It's the number of waves passing any point per second. The SI, or Standard International Unit of Frequency, is the Hertz. The symbol of it is Hz. What do you mean by frequency here? Here we said it's the number of waves passing any point per second. Let's take this point as the specific point, or the certain point, and we will see how many waves it passes during a specific time, or this time which is 1 second. Okay, let's if we will take this point and we will count during 1 second how many waves passed through it, we will see here it's saying 3 waves. Okay, 1, 2 and 3. So how many waves it passed during 1 second? 1, 2, 3. So the frequency here will be 3 cycles or 3 waves during 1 second. So here the frequency, it's what? It's equal to 3 hertz or 3 Hz. Number 3, wavelength. Wavelength, also each wave, it has different length. What do you mean by wavelength? This is the distance between any point on a wave and the equivalent point on the next wave. For example, if we will take this point where the equivalent point will be. So the equivalent point will be here. Equivalent point, what do you mean by equivalent point? Same point in another place. So the distance between these two parts, the distance between these 2 points, sorry, okay, we call it wavelength. Another example, let's say let's use another color. Okay, let's say our point, it's here. Guess where the equivalent point will be. Will it be here, 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 or here? Take your time, guess. Is it number 1, number 2, number 3, or number 4? The correct answer, it's not 1, not 2, not 3. So it's number 4. Now, the distance from this point to this point, this we call it wavelength. Usually the wavelength, they use the unit meter to measure it. Then the 4th term, which is amplitude. Amplitude, this is the maximum distance a point moves from its rest. You should focus on these words. Maximum distance a point moves from its rest position when a wave passes. If you look at this wave, okay, here, this point, it's what? It's the rest. This is the rest point. So here it's starting point. The wave, it start going up, it start going higher from this point. So the higher the maximum point, the maximum distance this wave can reach, okay, we call it amplitude. So this wave, the amplitude of it, we will measure this distance from point A to the point B. And also the same thing, it's here. Here, the wave, it's going down, okay? So here it's starting point, okay? And here it's ending point. So the distance from this point to this point, we call it the amplitude. In the next questions or next slides, we will see how we can calculate it, okay? Here,
but I'll show you exactly what they mean, and you'll see they're quite straightforward. Okay, I'm showing you here a transverse wave, and we looked at these in a previous video. Now, all waves have got certain key features which you've got to be able to label. We're going to start by looking at the amplitude. I'm showing the definition of amplitude here. The amplitude of a wave is the maximum displacement of a point on a wave away from its undisturbed position. So what does that actually mean? If we look at the wave, we can see a point in the center where the wave is not moving, and I'm showing you that here. This part of the wave is undisturbed. The amplitude is the furthest point the wave vibrates from this undisturbed position. So this is the amplitude, and also this is the amplitude. Now, the amplitude is very difficult to label on a longitudinal wave. So if this comes up in your exam, it's likely to be a transverse wave like this one. Okay, the next key feature of waves is the wavelength, so we're going to look at that now. Here's the definition. The wavelength of a wave is the distance from a point on one wave to the equivalent point on the adjacent wave. So what does that mean? Well, if we take a point on one wave, for example the top, and then measure the distance to the same point on the next wave, then that's the wavelength. And I'm showing that here. Now this works for any 2 points on the waves. So we could also measure the wavelength at the bottom of the waves like this, or even in the middle like this. Now the wavelength has a special symbol which I'm showing you here. This is the Greek letter lambda, and we'll be seeing that again in the next video. Now we can also measure the wavelength on longitudinal waves. In this case, we measure from one compression to the next compression, or from one rarefaction to the next rarefaction. Okay, the next property of waves is the frequency. The frequency is the number of waves passing a point each second, and the unit of frequency is the hertz. 1 hertz equals 1 wave per second. Now in the exam, you could be asked to work out the frequency of a wave from a diagram. So let's look at that now. Here's a transverse wave with the time shown on the bottom. You can see that this represents 1 second. To work out the frequency, we need to count the total number of waves. We can count 1, 2, 3, 4, and 5 waves. So that means that the frequency is 5 waves per second. In other words, 5 hertz. Here's another wave, and this one's got a longer wavelength. So again, to work out the frequency, we need to count the total number of waves. In this case, we've got 1, 2, and 3 waves in 1 second. So the frequency is 3 hertz. Now, the final property of waves is called the period. The period is the time in seconds for one wave to pass a point. We calculate the period using this equation. This is given to you in your exam, but the units are not given, so you need to learn them. The period in seconds equals 1 divided by the frequency in hertz. Here's a sample question for you. A wave has a frequency of 100 hertz. Calculate the period of the wave. So pause the video and try this yourself. Okay, so the period is 1 divided by the frequency. The frequency is 100 hertz. Dividing 1 by 100 gives us a period of 0.01 seconds. Remember, you'll find plenty of questions on the properties of waves in my revision workbook, and you can get that by clicking on the link above.
Okay, so I hope the video was useful. Okay, he just mentioned one point that you should focus on it. Sometimes sometimes the formulas will be given in the questions, but you need to write the units. Okay, so as we explained in the class, as we focused always, we said you should know the units. So here it's the formula or the equation how to find the speed of a wave. If they will give you a wave, some information about waves, and they will ask you what is the speed of this wave, so you will depend on this equation to solve it. Speed equal to frequency times wavelength, or in symbols, this is V equal to F and lambda. Lambda, we said, is the wavelength. One more thing, it's how to find period. Okay, so frequency equal to 1 over period. We will have some math questions to solve this equation or to solve this kind of question. Now, math skills. If you look at this drawing, the waves on the right are traveling across water. So firstly, here they mentioned water. So what kind of waves are there in water? Of course, as we mentioned before, we said it's transverse waves. Each wave is 2 meters long. Okay, what's the meaning of 2 meters long? What do they mean by it? Okay, they mean by it the length. The length of these waves is 2 meters. So the wavelength it's 2 meters. Again, if you want to solve these math questions, we say the first step you will do it's writing the information that it's given in the question. So here what do you have? You have wave length, which is equal to 2 meters. Okay, 1 second later. 3 waves have passed the flag. So the frequency, it's what? It's 3. How do we know it's 3? Okay, it says here 3 waves after 1 second. Okay, so time here, it's how much? It's 1 second. Time, it's 1 second. And they said 3 waves passed in 1 second. So 3 over 1, it's equal to 3 Hz. So now what do we have here? We have frequency. Frequency, how much it is? It's 3 Hz. Okay, now the waves have moved 3 wavelengths, 3 times 2 meters to the right, so the speed. Here the question will ask you, find the speed. So the equation to find the speed, the equation it's what? Let's write the equation here. Speed, speed equal to frequency, okay, times the wavelength. Okay, but in the exam, don't write this formula. Either write the full words or you can write it as symbols. In symbols, you will write like this. V equal to F times the wavelength. You will do it in this way. The symbol, it's lambda. So now the second one, the second step, it's what? Replacing the words or the letters with numbers. Frequency, how much was the frequency? We say it here, it's 3, and also we mention it here. So here will be 3 times how much is the length, the wavelength. The wavelength here, it's given, it's 2. So 3 times 2 equal to 6. Now the most important part, which is 6 what? Okay, what's the unit? Which unit do we use to measure the speed? Okay, as we mentioned in the beginning of this lesson, we said it's meter per second. Okay. Questions. Now, I will solve the first question, and I will sum a part of first question, and you should do the rest by yourself. You should practice it by yourself. Okay. The waves in A below are traveling across water. This is A, this is drawing A, and this is the drawing B. So in A it says these waves are traveling across water. A, are the waves transverse or longitudinal? Okay, it's the second time that we are asking this question. We said waves in water, how they are moving, up and down or backward or forward. Of course, they are going up and down. So when it's up and down, so the answer will be transverse. B. What is the wavelength of the waves? The wavelength, we said, it's the distance between a point and equivalent, the distance between 2 points. The first point, let's take this point as an example, and the equivalent point of it. The equivalent point of it, it's where? It's here. So that now, to find the distance, it's what? It's the distance between these 2 points. How much is the distance between this point? This, it will represent the wavelength. But how we will calculate it? If you look here, it says 1 meter. Okay, each 2 squares, it's 1 meter. So now let's count how many squares are there between these 2 points. 1, 2, 3, and 4. So each square, it's 0.5, 0.5, 1, 1.5, and 2. So the answer for the wavelength, it's what? It's 2 meter. C. What is the amplitude of the wave? As we explained before, we said amplitude, what do you mean by amplitude? It's the maximum distance from rest. So here we have the wave. The rest point, it's here. So the distance now from here to the maximum, how much it is? Again, we will depend on this scale, which says each 1 square, it's 0.5. 2 squares are 1. So how many squares do we have from this point to this point? It's only 1. So the answer will, amplitude here will be 0.5 meter. Okay, is that clear? Okay, now D. D, the question of D, it says if 2 waves passes the flag every second. So here they didn't give you numbers, but they gave you words. So you should focus on these words. If 2 waves pass the flag every second. So what is the frequency? Okay, what is the frequency? So how we can find the frequency here? Okay, who knows? No, because it says 2 in 1 second. So the frequency here will be 2 hertz, H, Z. Okay, then period. Period, as we explained before, we said it's when, okay, let's solve it here. Period, okay, equal to 1 over frequency. So 1 over frequency, how much it's 1 over frequency? It's 1. How much is the frequency? It's 2. So 1 over 2. 1 over 2, it's equal to 0.5. But 0.5 what? Okay, it's the answer, it's S second, 0.5, okay, second, okay. Now E, F, G, it will be on you. So this will be your homework. Have a good day. Thank you. I hope this video was useful. If you have any questions, again, don't hesitate to text me.